Hello class, so here's the video finishing that problem 3 from section 4.2. This is talking all about residuals, so I had to type this out real quick. For the residual, the definition of it is the observed minus predicted. That's how we calculate each residual. The observed is just the answers that you have in list 2. So in our calculator, those will be all the list 2 values. The predicted is the trickier part. Predicted is what the answers that you would get when you plug the x values into the line that you're dealing with. Okay, so list 2 minus the answers from the equation of the line. So let me show you that back here on the homework. So I'm going to take these list 2 values here. Those are the observed. And then the predicted are the numbers that I would get when I take each of these x values and plug them into the equation. So for part for part F right here, it wants me to calculate the sum of the squared residuals for the line that we found in part B. So that's this one. So again, the observed values are the y values. The predicted values, I'm going to take this equation, this 3x minus 1, and for the x, I'm going to plug in these x values. I'm going to plug in 2, and then I'm going to plug in 3, and then I'm going to plug in 4. And I'm going to do it each time, and I'm going to subtract the y value from the answer I get when I plug that number into the line. Now, there's only 5 pairs of numbers here, so I could do them each individually and calculate them all, but it's easier to get the calculator to do it for me. So here's what I'm going to do on the calculator. So stat into my list. I already have list 1 and list 2 entered in. So in list 3, I'm going to do a formula. I'm going to do observed minus predicted. The observed values are all of the list 2 values. So this is doing that. List 3 will be my residuals. So back from the Word document, remember, observed minus predicted. So the observed is list 2. I'm going to minus, and then in parentheses, I'm going to put the answer. I'm going to get the calculator to calculate all of these values when I plug these x's in. So I'm basically typing in this equation right here, 3, but instead of the x, I want to plug in those x numbers, which is list 2. So list 1. So I'm going to go 3 times the list 1 numbers, and then the minus 1, subtract 1, close the parentheses. So list 2 is the observed, all of this is the predicted, and I'm subtracting those, so that'll calculate the residuals for me. Okay, so the residuals are 0, 0, 1, and 0, 0. The reason 4 of those numbers are 0 is because right here when I graph this line, notice this line goes through 4 of these dots. It goes through that dot, that dot, that dot, and that dot. That means the residual right there is 0 for those numbers. Residual is basically the error. It's saying how far away the line is away from the dots. So the residual is 0 for those. For this one right here, the residual is 1. So the line, and I know it doesn't look like it looks like they're pretty close, but the line is actually 1 unit away from the dot right there. So that's why we got 1 in that position there. Okay, perfect. So now back on the blank screen, this part, what part are we on? F, wants me to calculate the sum of the squared residuals. I want to square all of these numbers I got in list 3, which is pretty easy. Most of them are 0. And then I want to add them all up. I can get the calculator to do it for me. I'm only showing you this formula not because you wouldn't be able to do this by hand, but in case the numbers are all different, like it will be in the next part, you can get the calculator to do it all for you. So I'm going to do the sum function. So second function in the stat, over to math, and down to number 5 is the sum. So this will add up a whole bunch of numbers for you. So I'm going to do the sum of the residuals, are the numbers that I have in list 3, and I want to square them. So that's what this is saying here. Compute the sum of the squared residuals. So that's exactly what I'm doing here. Close the parentheses and hit enter, and I get 1. So that's why I put this 1 in the answer here. Okay, part G, I'm going to do the same thing. I'm going to do it all over again, but I'm now doing it for this line we found in part D. So I'm virtually doing the same work, but these numbers are going to be different. So I'm going to go back into stat, hit enter. I'm going to do it in list 4 instead of list 3, so I can leave those numbers there. So in list 4, I'm going to do observed minus predicted. The observed is still the list 2 values. That hasn't changed. I still subtract, and then all of this, I'm going to get the calculator to do all of the predicted part for me. So instead of the 3 that I used before, I'm using this 2.977. 2.977. I want to, instead of this x, I want to plug in all of the list 1 values. So I'm going to do list 1, and then I'm going to go minus 0.698. Close the parentheses. So again, it's hard to see it all at the same time, but I'm doing list 2, which is observed, minus, and then everything inside the parentheses here is the predicted, and I'm going to get the calculator to calculate it all for me. Hit enter, and it gives me all these numbers. Now, some of them are negative, one of them is positive. They're all off by a little bit. in part E, notice the line we graphed for this one. This line doesn't go through all of those dots. It's close to them. It's very close. The picture's not very good, to be honest. We can zoom in on a little bit. It doesn't go exactly through those dots like it did in this part here, in part C. So our line's off by a little bit, but as we're going to see in the last part, that doesn't mean it's worse. It's the worst line. It's actually the better line. So I'm going to go back to the blank screen. I'm going to calculate the sum of the squared residuals for list 4 now. So I'm going to go second stat, over to math, down to sum. I'm going to do it on list 4. I'm going to square those numbers, close the parentheses, and hit enter. And notice my number here is 0.797. It's smaller than 1. So this number is telling you basically how good is your line. In this case, it's kind of like adding up all of the errors, putting them together. So the errors for the line we calculated by hand was 1, and the errors for the other line is smaller than that. It's 0.79. So it's slightly better. So I rounded it off, put 0.791 in for G, and got that answer right. And then part H, comment on the line found in part B versus the least squares regression line in part D. So we want to compare the two lines, see which one is better. The line in part B passes through the most points. So initially you would think that that line is better. But the line in part D minimizes the sum of the squared residuals, meaning the amount of error is smaller, thus being the best fitting line. So we can check that answer and see that that works. Okay, sorry, that's kind of a long video, but look that over. Let me know if you have any questions, and keep up the hard work.